Today, we are going to give you an answer to the question in your mind, asking, how do I want to implement Industry 4.0 successfully in my organization? We will remove the mist covering a successful Industry 4.0 implementation in your organization. But how are we going to do that? In today's presentation, we cover 2 case studies of successful Industry 4.0 implementation at Georg Jordan, Malaysia SDNBH, covering supervisory, control, and data acquisition. For each and every case study, we will talk about its background, so you will get a brief understanding about the project. Secondly, we will talk about the challenges we faced during the project execution, during the implementation phase. Thirdly, we will see what we will get by implementing SCADA in our manufacturing processes. Did we achieve what we wanted to achieve, or did we fail to get our results? Lastly, we talk about the next steps, because we never stop where we are now. We always move forward. For each case study, 2 takeaways are provided. That rounds up the technical side. Secondly, we will talk about your money, your organization's money, and how to get it back. We talk about the return on investment and what makes it difficult to calculate it reliably. We provide an alternative to you, the discounted payback period, and discuss its advantages and its application to your projects, to your organization. That closes the loop. The technical part has been discussed, as well as the financial side of the projects. Afterwards, we move into whether we should scale up our internal resources or use external Industry 4.0 solution providers to support our organization. With that said, we concluded all together and give you another 3 key takeaways from today's presentation. Let us jump into our first case study. Supervisory, control, and data acquisition for ovens. At figure 2, you can clearly see an oven. It is an oven used in our critical process. The oven is my age. It is very reliable. It is using manual timers and temperature controllers, which have no digital footprint, no digital documentation. The process was stable, but we want to know what is going on in our ovens in real time. At figure 1, we can clearly see on top of the train, one of our products used as an insulator between top high voltage and ground the train. If that insulator fails within the next 30 years, the train can't move. So we have to make sure that our process, especially the ovens, are operating stable and as we want them to operate. The stakes are high. That was the reason why we implemented supervisory control and data acquisition for our 7 ovens. We wanted to control the oven temperature and get live information about what is happening in each of the 7 ovens. We want to look at the temperature curves, not only now, also after a couple of years. So we have to save the temperature curves. We want to control the operations, not only at the oven level, but also at our computer. At the end, we need trends, we need graphs, we need to generate reports and alarms if anything goes wrong. That is the background of the process. Let us see how we implemented and what challenges we faced. I have to admit, we made a very huge mistake. We allocated to save cables, to save wiring, we allocated the server next to the ovens in a high temperature environment and in an industrial environment. That caused our equipment to shut down frequently, and we did not achieve our 100% uptime, what we wanted to have. In figure 3, we see our products. All these products are waiting for the next process. The customers are waiting for the products. The pressure built up. Did we give up at that moment? No. We made sure we made the only logical step and moved the server and the critical equipment to an air-conditioned server room and achieved 100% uptime for the next years. On top of that, we are able to perform our maintenance and enhancement in-house and thus saves valuable time and valuable costs. All functions we stipulated in our background, we fulfill 100%, and we are really glad that we achieved a very stable process. We went from chaotic and unreliable to 100% controlled and stable. But did we stop in this moment? No. We are moving on, and since 2080, we monitor the energy consumption of our whole factory, equipment by equipment. We are able to identify what causes our electricity bill to be so high. The ovens are one of the key issues. Thus, we only let them run in the night to make sure that we save some electricity bill because the rates are lower in the night. And secondly, we improve the internal of the oven so we are able to stack it properly and run it less frequently. On top of that, now we have our material requirements planning system on the one side, where we store all our information, and our SCADA system on the other side. These two are now seamlessly integrated and functioning well together. From this project, there are two key takeaways I want to highlight. First, always have redundancy. In case your SCADA system is down, you still have to go back to your manual system and make sure your process can run without the uptime of the SCADA system. Secondly, keep in mind your environment. Most of the equipment is only reliable at an ambient temperature of 40 degrees. Don't overdo it. Your server usually needs air conditioning, as human also. With that, I would like to close the first case study and look at another great example of how we can improve the process. The heart of our organization, the mixing department. At figure 4, you can see our small batch mixers where our products are getting the material they need. We are getting the raw materials from our supplier, but the actual mixing process we do in-house with our mixers. The process is absolutely critical to our success and to our products that they last 30 and more years. We started out by manually documenting all the processes we did. That worked out fine, but we definitely want it to be monitored and controlled also digitally. We can't rely 100% on manual filled-in sheets. The TV you can see here is after the implementation, whereby our material requirements planning system is working seamlessly with the SCADA system and thus capturing all the values we need. Let us now look at the challenges we faced during the implementation. There are two challenges I would like to present here. First, the timeline. We expected that we definitely can complete the project in a couple of months, get it smooth, get it running, and we didn't do it. We needed over 1 year. Why did it take so long? In retrospect, we did not share all the requirements to our external solution providers. They assumed they know what they need, but unfortunately that did not match with our requirement. So, an example is the accuracy of the scale, pictured in figure 5. We really have to have it accurate, and we told our external solution provider we have to have a very accurate scale. But our mistake was not to exactly specify what is the tolerance, and thus we got into trouble. It took us more time than expected, and we had a lot of delay in the process of implementing the project. Did we give up and just let the timeline be the timeline? No. After over 1 year, finally we were able to 100% monitor and control all essential raw material preparations, all essential components, each and every shift, each and every day. Our SCADA system is seamlessly integrated with our material requirements planning system. And thus, now we have two types of record keeping. On the one side, we still continue with our manual system. On the other side, we add the digital footprint and get the values each and every day. If anything goes wrong, we can compare both and judge out of that. Did we stop here and said, now we have SCADA for mixing? That is sufficient? No. We are looking into the automatic filling of our components. In fact, we already started a project, and by end of this year, we expect that we are going to have an automatic filling of all our components, all our materials/recipes. Let us now look into two key takeaways to avoid the challenges we faced. Firstly, we have to provide the external service provider all the information they need. It is great to provide to them the project charter and a detailed requirements list, so they exactly know what they have to do. They can exactly calculate their costs and thus give you a better price in a shorter period of time. Secondly, communication. It is best to sit down with the external service provider and just ask him whether he needs to know anything, walk him through the process so he really understands the individual problems your organization and your process faces. By doing so, you reduce the financial impact on your organization and get the project done in time. With that, I would like to close our technical part of the presentation. Now, we look into the numbers. We look into the money, your organization's money, and how to get it back. On the left side, we have the usual calculation, return on investment is your net income divided by the cost of investment times 100%. On the other side, we see the discounted payback period, which returns you at the end of the day the number of years you need to wait until you can break even. Usually, everybody uses the return on investment calculation, but there are three key difficulties I have to highlight. First, the return on investment calculation does not keep in mind the time. It does not look into the time value of money. And thirdly, it is easy to manipulate coming from external parties. What is the alternative to the return on investment basic calculation? The discounted payback period. That is what I recommend and what we use. We just say we have our years pre or fully recovery plus the unrecovered cost at the start of the year divided by cash flow during full recovery year. At the end, you will get a number. For example, your break-even point will be after 3.2 years. There are definitely more sophisticated and even better calculation methods, but the discounted payback period gives us the years until break-even, and that is what we want to know. Let us not stay at the theoretical part. Let us look into an easy example to make the point clear. Our yearly net income is 250,000 ringgits. Our initial investment, our capital expenditure is 1 million ringgits. The number of years we will get a net income is exactly 5 years. Thus, at the end of the day, our return on investment is 25%. That really sounds great. If somebody comes to me and says, Simon, your return on investment is 25%, now or never invest your money. I would definitely go for it. Finding out afterwards that there's no calculation inside, that we have to keep in mind the cost of capital. There is not a timeline mentioned, which is actually 5 years. So after looking at the 5 years and that is not discounted for the time value of money, I wouldn't go for it. That is proven by the discounted payback period. Our cost of capital is 10%. Our yearly net income, as the previous example, is also 250,000 ringgits, and the years we get it back is 5. So the left calculation and the right calculation, the numbers did not change. But because we keep in mind that our cost of capital is 10% year by year, the amount, the actual time value we are getting back is becoming less and less, starting from 227,000 to the last year only 155,000 ringgits. After we sum up all the values, we look at the numbers and say, we only get back 948,000 ringgits. Where are my 52,000 ringgits? Where did it go? By looking at a project from this perspective, I definitely would say I can't go for the project because 5 years is too long. We never know what is going to happen in 5 years. And secondly, where do I get back my 52,000 bringt. Let us now go back to the next slide and look which particular way we should go. What is our guideline to decide? Return on investment calculations, the basic calculations, are very helpful for you, as long as you do the calculations yourself and you exactly know what you assume. I would be definitely cautious if external parties are presenting you a very favorable return on investment. That said, for external calculations, I recommend that our years until break even should be below 3 years. And we can use our cost of capital, we can just estimate as 10%. That is the financial side of our presentation. We already covered the technical aspect, and now we already covered the financial aspect. Let us now look into whether we should go for staffing up our plant, whether we should rely on internal resources or we should hire external solution providers. The next slide reveals an answer. For each and every option, I present to you here 4 distinct advantages. Let us now look in scaling up our internal resources and rely on internal resources to start and endure Industry 4.0 projects. Firstly, internal resources always have a deep knowledge of your internal processes, so they exactly know what you have to do. Secondly, if internal resources perform the implementation of Industry 4.0 projects, they definitely can do the maintenance and enhancements for your projects and thus save you significant costs in long run. Thirdly, all your critical process information are kept in your organization and no external party gets it to know. Lastly, your internal staff will definitely gain knowledge and will understand it and can apply it for the next project. You don't have to train them again and again. That was the internal side. Let us now look whether we should better rely on external Industry 4.0 solution providers. If you hire external, you definitely hire a specialist. They know what they have to do. And secondly, they usually implement best practices. Thirdly, you definitely got a lot on your plate. Once you outsource Industry 4.0 project implementation, you get to look on your operations and on other critical aspects. Fourthly, according to the Federation of Malaysian Manufacturers, there are 200 Industry 4.0 solution providers available in Malaysia. So you definitely find the right one for your organization. Which way should we go? Should we rely on our internal staff or should we go for external solution providers? Let us merge it together. The project initiating and planning phase should be done with our internal key personnel. The execution, meaning the implementation, is recommended to be done by external solution providers. But they shall be augmented with internal staff. Thus, the maintenance of the projects and the enhancement can be done in-house and saves you a lot of cost and time in future. We looked at all the 3 parts. Now let us wrap it up together and come away with 3 key takeaways. If you forget everything what I said so far, I'm totally fine with that. There's no issue. Just let us keep in mind 3 key takeaways from today's presentation. Firstly, let us make the documentation clear. Before we even start to think about implementation, we should do a thorough planning and project initialization. We should see what we want to achieve. How can we do that? By following a simple 3-step formula. Firstly, we rank our projects according to the ROI and discounted payback period. The shortest payback period, the best. Secondly, we look at our capital expenditure and rank all our projects according to the capital expenditure. And then only we start to implement the projects with the most promising discounted payback period and the lowest capital expenditure. We only can successfully implement Industry 4.0 projects in your organization if we make sure that we cooperate together with our external solution providers. By working together, you definitely gain knowledge and gain insights, and thus you can apply it for your next project. The technical side is one problem. The financial side is even more important. We have to do a thorough study and calculate our return on investment and our discounted payback period before even we start to implement the project. Let us revive the growth of the Malaysian manufacturing sector. Industry 4.0 is our rocket. Let us make sure that it's flying into the right direction. Thank you.
Thank you very much, Simon.
Thank you.